All right, so in this video, we're going to be talking about the characteristics of a rational function. You will not have to graph in this class. We'll just be doing the characteristics. So points of discontinuity are going to be places where the graph is discontinuous. Or is not continuous. So that means there's either going to be a hole or a vertical asymptote. A hole, we're going to set our common factors equal to 0. This will always be a point. So your answer should be an x and y point when you get it. So you're going to solve for x by setting the common factor equal to 0, and then you're going to plug that x value back in to get your y. Vertical asymptotes, we're going to set the factored form, the base there, or the denominator, equal to 0, and that'll give us our vertical asymptote. Horizontal asymptotes, we're going to go back to the original problem, and we're going to look at the powers that are in front. If it is bigger on bottom, okay, so that's Bobo, bigger on bottom, y is going to equal 0. If it is bigger on top, then it's going to have no horizontal asymptote. It's actually going to have a slant. If the coefficients are the same, you're going to use the ratio of the coefficients. Then we've got our x and our y-intercept. The x-intercept, we set the numerator equal to 0 after we factored, and the y-intercept, we actually plug 0 into the remaining equation and solve there. The other important thing you're going to have to do is domain and range. Domain's going to be affected by the x value on our hole, and the range will be affected by the y value from the hole. And then the domain will also be affected by the vertical asymptote. The range will be affected by the horizontal asymptote. So let's look at our first equation here. Your first step should always be to factor. X minus 3 is going to stay in the top. And we're going to factor the bottom to get ourselves x minus 3, x minus 2. Okay, they have a common multiple, so that piece can come out. So we're going to have 1 over x minus 2 as our factored form. Now that piece that I scratched out is going to be used for my hole. So I'm going to say x minus 3 equals 0. So x equals 3 would be a piece of my hole. Now I need to find the y. So I'm going to go back up to my factored form, and I'm actually going to solve for y by plugging in the x I found. So I've got 1 over 3 minus 2, which gives us a value of 1. So my hole is going to be at 3, 1. Vertical asymptotes we get by taking the base or the denominator of our fraction and setting it equal to 0. So we have x minus 2 equals 0, or x equals 2 for our asymptote. For the horizontal, we're going to go back to the top. We're going to look at the coefficients. We're going to look at the powers. And if the coefficients are the same, or if the powers are the same, we look at the coefficients. But here they're not. It's bigger on bottom, which is Bobo, which means that y is going to equal 0. X-intercept, we take the top and we set it equal to 0. In this case, it's just a 1, which we can't have, 0 equal to a 1. So there are no x-intercepts there. For our y-intercept, we're going to take 0 and plug it back into our remaining equation. So we've got 1 over 0 minus 2, which will give us a negative 1/2. Now, a y-intercept is actually a point. So the y-intercept, the x is always 0, and then negative 1/2 would be our y value. Domain is affected by our hole and by our vertical asymptote. So for the domain, we're going to go to the hole and look at our x value that we had, which was 3, and our vertical asymptote, which was 2. So rational functions are going to come from negative infinity to wherever our smallest piece is. So 2 is smaller than 3, so we'll go there first. So we're going to go to negative infinity to 2. Union is a little u. And then we go from 2 to 3. And then another union from 3 to infinity. Okay, we're just putting breaks in wherever there's holes or vertical asymptotes. For the range, again, that's affected by the y of our hole as well as our horizontal asymptote. So we're going to again come from negative infinity, and our smallest one is 0. Union 0 to 1. Union 1 to infinity. And that would be our domain and range for that one. Our second one here. So if we factor the top and the bottom first, the first thing that can come out of the top is a 3. So we're going to have x squared plus 12x plus 27 in the top. In the bottom, we take out a 2. So we've got x squared plus 14x plus 45. And if we keep going there, we've got still the 3 in the top. When we factor the top, we're going to have x plus 9, x plus 3. And in the bottom, the 2 still in front, and we've got x plus 9, x plus 5. So the x plus 9s will cancel out, and our factored form would be 3 times x plus 3 over 2 times x plus 5. Okay, the whole, again, we get by taking out our common factor, which in this case was x plus 9. So we set x plus 9 equal to 0, and we get x equaling negative 9. We're not finished yet. A whole is a point. So we're going to take negative 9 and plug it into what's left to get our y. So we've got 3 times negative 9 plus 3 over 2 times negative 9 plus 5. So negative 9 plus 3 gives us a negative 6, times 3 gives us a negative 18. On the bottom, negative 9 plus 5 gives us a negative 4, times 2 gives us a negative 8. So we get 9 over 4. So our whole is going to be negative 9 and 9/4. Vertical asymptote, we take the base. So 2 times x plus 5 and set it equal to 0. We divide by 2, so then we get x plus 5 just equals 0. Or x equals negative 5 as our vertical asymptote. Our horizontal asymptote, we go back to our powers. Notice that they are the same, so we're going to use the coefficients in front. So y is going to equal 3/2. X-intercept, we're going to take the numerator and set it equal to 0. So 3x plus 3 equals 0. So again, we've got x plus 3 equaling 0, or x equals negative 3. Okay, again, x-intercept is a point, so it's going to be negative 3 comma 0, because the y is 0 when we have an x-intercept. Y-intercept, take 0 and plug it in for everything that's left. So we've got 3 times 3 in the top, because 0 plus 3 is 3. And then in the bottom, 2 times 5. So we've got 9 over 10. So our y-intercept will be 0 comma 9 tenths. Okay, domain. Domain's affected by the whole with the x value, as well as the vertical asymptote, which is negative 5. So we're going to go from negative infinity to negative 9, union negative 9 to negative 5, and then from negative 5 to infinity. All right, last part is the range. So for range, we're affected by the y of the whole and our horizontal asymptote. which is 3/2. So 3/2 is smaller than 9/4. So we're going to go from negative infinity to 3/2. And then from 3/2 to 9/4. And then from 9/4 to infinity. All right, last problem here. Again, you're going to factor the top and the bottom. So x can be factored out of the top and the bottom. So we're going to have x squared minus 9 still left in the top. And x squared minus 2x minus 3 in the bottom. The top is a difference of squares, so we can keep going. We've got x minus 3, x plus 3 in the top. And then in the bottom, we've got x minus 3, x plus 1. Then x in the front, as well as the x minus 3 will both cancel, which means we've got 2 wholes. And that leaves us with x plus 3, x plus 1. So for our whole, we've got 1 that's x equals 0. And then we're going to plug 0 into what's left. So when we plug 0 in, we're going to get 3 in the top and 1 in the bottom. So we've got 1 whole at 0, 3. And if we have a whole at our y-intercept, it means we're not going to have 1. So we can already write there's none for our y-intercept because it's a whole. So we don't actually have a value there. Okay, the next one was at x minus 3. So there x would equal 3 because we set x minus 3 equal to 0. And then we're going to plug 3 in. So for our y, we would have 3 plus 3 in the top over 3 plus 1 in the bottom. So we're going to have 6 over 4 or 3 over 2. So our second whole would be at 3 comma 3 over 2. Okay, vertical asymptote, we take the base, so x plus 1, or the denominator. So x plus 1 equals 0, or x equals negative 1. For the horizontal asymptote, we come back here, we look at the powers. They're the same. The coefficient in the front of both of those numbers is y, so is 1. So our y is going to equal 1. All right, x-intercept. For our x-intercepts, we're going to take the numerator and set it equal to 0. So x plus 3 equals 0. So x equals negative 3. Again, this is a point, so negative 3 comma 0 is going to be our x-intercept. We already talked about the y. And now our domain is affected by our whole and by our vertical asymptote. So our whole now has 2 points. So we have a 0 and a 3, as well as our vertical asymptote, which was negative 1. So this is going to be a long one, so prepare yourself. We're going from negative infinity to negative 1, union negative 1 to 0, union 0 to 3, and then another union of 3 to infinity. My board is acting up, so I can't write the range on the bottom. But what you would have for the bottom, I'll try to do my best. Might panic. We've got the y value of our wholes for both, so 3 and negative 3/2, as well as 1. So we're going to go from negative infinity to 1, union 1 to 3 halves, union 3 halves to 3, and then union 3 to infinity. Okay, if you have any further questions, please see me in class.